An example of the third form for partial fraction decomposition is the function 15x squared minus 11x minus 5 divided by 2x cubed minus 3x squared minus 5x. Our first step is we want to factor the denominator. So the numerator we'll leave alone. We will use it when we solve for the various constants. But as far as setting it up, we're going to just leave it alone. So the first thing I want to do in factoring out this denominator is I want to actually just take an x out. So I'll be left with 2x squared minus 3x minus 5. Now that that x is factored out, I have a quadratic, which is a lot easier to factor. As far as this quadratic goes, because I have a 2 as a coefficient in front of that x squared, one of these coefficients is going to be a 2 and the other is going to be a 1. Now I look at, it's going to not just be a straight up combination of a product of 5 and an additive of -3. Because I have that 2 there, it's going to change the numbers in here slightly. But the signs should be the same. One of these signs is going, because I have a -5, the only way I can get a -5 from a product of two numbers is to multiply a negative and a positive. So the signs in here are different. Now it's just determining which ones are different. And I'm going to put the negative by the 2 because the -5 isn't a really large number. This -2 is going to be multiplied to whatever number goes here. So that number I don't want to be too large. And this is actually useful for us because 5 is a prime number. There are only two numbers that I can multiply together to get 5 and 1. So how can I orient those numbers to get me -5 and -3 when I also incorporate that 2? I'm going to put the 5 by the 2 because I don't want to multiply 2 to 5. That would give me 10, and 10 is too large of a number to work with. So I'm going to put the 5 by the 2 and the 1 by the x. And if I were to FOIL this back out again, I would see that this becomes a 2x minus 5x, which gives me the -3x, and then the -5 times the +1 gives me the -5. So now that this is factored out, I can see that it fits more of my third form. So I'm going to set it equal to a over, and I'm going to write x instead of x minus a, plus b over 2x minus 5 instead of x minus b, plus c over x plus 1 instead of x minus c. And now you might notice we have 3 terms, but all of the rest of the principles are the same. Like the two previous forms, I want to get rid of this denominator, so I'm going to multiply it to each side of the equation. Cancels out on the left side, and then parts again will cancel out on the right side. This x will cancel with this a, this 2x minus 5 will cancel with this 2x minus 5, and this x plus 1 will cancel with this x plus 1. And that gives me this final form of the equation, 15x squared minus 11x minus 5 equaling a times 2x minus 5 times x plus 1 plus bx times x plus 1 plus cx times 2x minus 5. Now you might be tempted to FOIL this out, but it is actually unnecessary and makes it actually harder to solve for a, b, and c. Like the previous two methods, we're going to pick values for x to solve for a, b, and c, and the values for x we want to pick are going to be such that we want to cancel out either a, b, or c to make it solvable. Because currently we have 3 unknowns and just one function. So we need to manipulate it in some way, so we just have one unknown. To do that, let's let x equal 0. What does that do to our equation? The left-hand side just becomes -5. The right-hand side becomes a times -5 times +1 plus, and you'll notice that b is being multiplied to a 0. So it doesn't matter that I have a 0 plus 1 following after it. If I multiply anything by 0, it's 0, so it cancels out. And the same thing with the c. because it is also being multiplied by 0, it also cancels out. It doesn't matter what else comes after it. So I'm left with negative 5a equaling negative 5. So a equals 1. I'm going to substitute that into the original function, and instead of writing 1, I'm just going to erase a, because I know that anything multiplied by 1 is itself. So I don't need to write the coefficient. It's unnecessary. But I have it written up here, so we remember that a is 1, because we will end up needing it back in the original form. Now let's solve for the other variables, and let's let x equal negative 1. You can probably already start to see that's going to make the b cancel out, allowing us to solve for c. So the left-hand side of my equation becomes 15 minus 11 times the negative 1 becomes plus 11 minus 5 equaling, I've got 2 times negative 1 minus 5 times negative 1 plus 1, which actually ends up being 0, making this whole thing go to 0. Then b also will go to 0, because even though b is multiplied by negative 1, because it's multiplied again by negative 1 plus 1, that also goes to 0. And then I have plus c times negative 1 times 2 times negative 1 minus 5, which gives me negative 7. Then I get 21 on the left-hand side equaling 7c. So c equals 3. Now I'm going to substitute in my c and substitute that 3 in for c, and I'm going to pick any other value to solve for b, and just to make the math simple, I'm going to pick x equals 1. So let's let x equal positive 1 this time instead of negative 1. On the left-hand side, that gives me 15 minus 11 minus 5 equaling negative 3 times 2 plus, and I'm solving for b, I'm going to keep b there, b times 1 plus 1, which is 2, plus 2b2 plus 3 times negative 3. The left-hand side becomes negative 1 equaling negative 6 plus 2b minus 9. b equals 7. All that's left for me now is to plug it into our original equation and the format following Form 3. So a is 1 over x plus, instead of writing b, I'm going to write 7 over 2x minus 5 plus, instead of writing c, I will write 3 over x plus 1. And this is a partially decomposed fraction of Form 3.